biasing. The reverse biasing only works for some electromagnetic processes, so you can't use it for hadronic processes. I just wanted to make that clear. That's a big qualification.
For the case of this reverse Monte Carlo, gamma turned into electron. Because in a real world, electron spits, Bremsstrahlung. So gamma comes and makes the Bremsstrahlung interaction to turn into electron. So you really have to integrate all the triple differential cross sections. So it's not easy for hadronics at all. That's the point. Any other question? Don't be shy, please. Or you really want us to move to the next talks and go back for beer or whatever, or carnival? Yes, we can do that. Sure.
Concerning the lecture we had this morning, that when a particle is generated, it goes to the stack. And there is this category of postponing the calculation for the next event. When you're running multi-thread, I mean, when all this stack for this event is empty, so the simulation stops and waits for the next event,
yes.
Or the other
not stop, but once all the stack become empty, then no more particle could be popped up. This signal comes to the event manager, and the event manager say to the local worker manager, event is over, give me next event. So there's no stop here, but immediately next event starts. But if the local RAM manager does not have next event, it goes up to the master RAM manager asking for a bunch of events. And if master RAM manager doesn't have any more events, they wait and wait for all other threads to finish. That works. In that way it works.
Between the two events, you can interact because there is the event action. So at the end of the event, the end of event action is called, and if there is other event to take, then the beginning of event action will be called before the event.
Yes. But they should happen only within its own worker thread. You cannot transfer particle to the other thread. That reminds me of another issue, that if you implement your own program in multi-threaded mode, if you create an object, that object has to be deleted by the thread you create. That is true for the regular new, but also if you use allocator, Geant4 allocator, it instantly goes codon. Okay? It has to, because of controlled smart pointer broken. So if you create a hit, it will be nice, it will be visualized. Yes, we do it. But visualization is sitting in the other thread. So that, even threads are working, visualization can do something else to visualize. Then the visualization managers call back to the local thread, RAM manager. Okay, this event is already drawn. You are free to delete. So that this local RAM manager delete events or hits. Okay? So in the same way, if you create a hit, please, for the case of hits, you really have to use allocator. In this case, delete that hit object in this thread. This can be visible from all other threads, yes. So that you can merge, perfect. But to delete the object, you have to go back. Okay. Yes. Good question. The digit. Yes. we do have this kind of framework, but digitization. Digitization, yes. Yes, because we do have this mechanism, very similar design to sensitive detectors. We have digitizer class. But the only difference is, for the case of sensitive detector, if particle comes to the volume where the sensitive detector is assigned, this sensitive detector is automatically invoked. It's guaranteed. But for the case of digitizer, Geant4 cannot guess which digitizer should be invoked first, because, for example, this digitizer in reality, level 1 trigger, level 2 trigger, whatever, then it really have to be you, at the end of the event, saying, invoke this digitizer first, then using this digitized data and feed it to another level digitizer, and so on and so forth. Everything has to be written by you. We offer just a framework, and nothing concrete. And I'm afraid there's no example, because at least as far as I know, no one is using it. Because it's basically embedded inside experiment framework, most likely, because it is directly connected to the analysis or reconstruction code. So we do have a framework, and just a short document, but nothing else. Of course, Geant4 is an open source code. You can do anything if you want. Okay. Shall we go, maybe?
Okay.
Yes.
One final detail to deal with is what to do when you want to upgrade your release. So you now all have a nice, fresh, new copy of Geant4 10.5. But as usual with software projects, changes are constant. And we sometimes have bugs, and we have to put those in too. So I'm going to tell you how to distinguish between a major and a minor release in Geant4. And very important, to look at the release notes and what especially to look for in the release notes. And then finally, how to actually do the upgrade. So, the first day I talked about the Geant4 user support and the main web page. So up in this corner of the page, there's a news box. So pay attention to this, and you will see that this is where the next release is announced. It's also, this is where the patches are announced. So pay attention to that, and make sure that you're not too far away from the latest either major, minor, or patch release. Geant4 releases take this form. So Geant4 is the name of the thing, the toolkit. The version number starts with X, and then that is the major release, .Y, which is the minor release. So we are now in major release 10, minor release 5. So the rules, the reason we make this distinction, if it's a minor release, we're not allowed to break any user code. So you now are building things or will build things on top of Geant4 10.5. And you are entitled to know that the major interfaces and the workings of Geant4 will always be the same until we should go to version 11. At that point, we have to make sure that we don't change things in a way that it breaks your application. So that's kind of our promise to you, that between major releases, we don't make big changes that you can have a problem with. Minor releases, we can do that. I'm sorry, major releases, we can do that. Minor releases, we cannot. So you wouldn't expect to see many problems in going from 10.0 to 10.1. But if we go from 10 to 11, we may make some big change. For example, when we went from major release 9 to major release 10, multi-threading was included. So that obviously makes some possibly big changes in your code. So we have to respect those rules ourselves so that you know what to expect. Patch releases deal with bugs. And so the patch release number will end in P01 or P02. So Geant4 10.1.P01 was minor release 10.1, and there was a patch P01. Hopefully we don't have too many of those, but we always have bugs accumulating, and we put out a patch release as quickly as we can. So the rule for the patch releases is that they may only contain bug fixes. No new features are allowed. No interface changes, no new physics. It only has to be bug fixes. Best idea to really download the latest patch, especially after a new release. Okay, so we're 10.5.0. There's a patch release now already. Please get it. But keep up to date on the patch releases. And that tells you exactly, we have release notes which tell you exactly what was changed. If you are the adventurous type and you like to live dangerously and you like to get the very first release, then we have beta releases. So in June, usually June of every year, we produce a release which has all the latest features, but which have not been sufficiently tested yet. And we do this because some users really like to get the latest stuff and start testing it. And this is also very helpful for us, because if we have power users out there who test the new software and say, this doesn't work, that doesn't work, that's great. That means we can fix all this stuff before the appropriate December release. So it's a very good thing. You will see the release designated by the extension .beta, 1, 2, or 3. So in June, we'll have Geant4 10.5.beta 1. Or is it beta 0? I forgot. Anyway, it'll be a beta. So, good thing to use if you like to test code. Very important to read the release notes. So on the Geant4 download page, you'll see a link for the release notes, and it looks like this. So here's the download page, and then right here is a link that says release notes. And that brings you to another page here. And this tells you a whole bunch of useful information for what to do with the new release. I'll go through a few of them. I'll talk about the supported platforms and compilers that you need, the CL-HEP version, migration issues, and then, very important, the expected effects on physics and performance. Supported platforms and compilers. This may change at any major or minor release, so you have to pay attention to it. And if your platform and compiler are no longer supported, either you have to upgrade or try what you have. In a lot of cases, we may say, please go to the next compiler version. But as long as it still works and builds for you, go ahead and keep using what you're using. I myself never change the compiler unless something breaks. So if it builds and starts, don't worry. If you do find problems, then you have to go back and look at this. So it's item number 1 on the release notes, and it tells you the officially supported platforms. And we also have a few that are not officially supported, but they are very well tested. So these are probably also okay. Just check this list. Geant4 offers 2 ways to access the computing library for high-energy physics. It is a math library, basically. We have one subset of this library which is compiled directly within Geant4. For most everybody, this is sufficient. It's what I use. Some people like the full thing, and so there's a separate version that you can download for CLHAP if you need it. And if you want to build that in, you have to have the appropriate build tag, so you have to have the -D option in the CMake to let it know that you're going to use this. But check to see that the CLHAP version that you're wanting to use is the appropriate one. Migration. So this usually doesn't happen for the minor releases. It usually happens in the major releases when we make big changes. And in that case, we try to set up a progression of code changes that make it a little bit easier for you to modify your code for the new major release. And so we issue a list of things that you would have to do or be aware of in the release to change your code to come up to the major release. So generally, don't worry too much about what might happen for the minor release. For a major release, always look at this, because there could very well be migration issues for you. Physics and CPU performance. So we write usually a lot of information here. And it's usually listed by category. So electromagnetic physics will write what they find out about CPU speed up, for example, or new functions that are running faster, or some new physics performance that has been added. Hadronic physics also, and any other category involving physics performance is included here. So everybody who improves a model has to put something here so that you know what you're getting. How do you do the upgrade? The upgrade, few steps here. First thing you do, as I mentioned, check the release notes, as we just talked about. Make sure the existing operating system and compiler are okay. First step. Follow the recommended installation instructions. So some of you have already done that. That's good. What you want to do is make sure, and you already know this because we've told you and you've done it, make sure that you're putting your code, your application code, in a separate work area. If you have a version of Geant4 that you have checked out, and within that Geant4 directory you put your nice application that you spent hours on, or days, or years, then you get a new version of Geant4 and you accidentally wipe it out, too bad. So that's why it's a good idea that you always put things in a separate directory. Keep your user code separate from the Geant4 installation. Patch versions. So if you are getting a patch version, you can lay it over the existing Geant4 version, but that's not recommended. There can be problems that occur. So we recommend that you just take a different directory and download another complete version of Geant4 that has the patch. That's the best thing to do. And then rebuild that and work from that one. Once again, unpack the new version in a new place, so it's different from the old version that you were working on. And another one, this you've also seen in the hands-on, because we've done this a lot. Always check your environment variables. So in Linux, it's printenv, and then pipe that to grep, and look for the character G4. So you will see all of the environment variables that are set. If you log out and start on again in the next day and you set up all your environment variables, they will be fine. But if you leave the same window open and start working in it again, you will see a lot of environment variables are still set, and they will interfere with the build or any upgrading that you do. So make sure that this is always cleaned. Once again, make a fresh Geant4 build directory, which is parallel to the source, and a fresh application build directory. So keep things separate. That's a key thing. So we've gone through just about everything. So here's the troubleshooting list. If you have a problem, First thing, read the release notes. See if there's anything there that affects what you might be doing. Did you remove all the pre-existing Geant4 environment variables? So that was that previous command, the print env, to let you know what the situation was. Put everything in a new build area when you have a new release. And when all else fails, read the installation and configuration forum. Okay, this is one of the forums on the Hypernews. Lots of questions there saying my code doesn't work because I did X. Okay, lots of questions have been answered there. Please go through that. Lots of answers there too. So most likely your problem will have been answered already. And if you get really stuck after all of that, then talk to a Geant4 expert. And that's it for upgrading. Questions? Yes?
So when are you planning to have the next major release?
That is a variable. Makoto, you want to?
I'll get something later in my talk.
Okay.
He has an official answer. Okay.
Okay, now, sorry, come to the very, very end. Where am I? Okay, so this is a very short concluding remark. So, three of us, Mihari, Dennis, and myself, we really hope that this tutorial course was informative, maybe too much, yes, and useful, okay? And also, three of us, we do appreciate Mauro, Mauricio, and Marcelo for inviting us to this wonderful, wonderful place. Actually, we just about Slack, we had already made the tutorial many times. This is our sixth continent. We have done a lot in Northern America, of course, in Asia, Europe. We went to Africa already, and we went to Australia once. So this was the only second remaining. But the last one, I don't know. We think we are going to just deep south for there. Anyway, so we are really pleased to be here. And we are discussing with Mauro that we may consider any additional tutorial later that could be, that could take care of the advanced topic or what we may ask you to give us the input so that we arrange our talk according to your request. That could be doable. So whatever could be arranged, okay, so just let us know, okay? Or let them know. Okay. And so let me add just a few more slides for the following up and just a bit about our future. Okay. The first is following up. As Dennis said, please keep maintaining your Geant4 installation updated. Our current version is 10.5, but likely before Easter, we have 10.5 patch 1. Patch release. And unfortunately, there's no regular patch release. So please check our webpage regularly, or easier thing is that register to our announcement mailing list. it is fully controlled, I guarantee, because there is only 3 persons in the world who can send out announcement, including myself. And we never send you any spam, for sure. And we don't even send any job solicitation at all. We are strict here. We send just announcement of the release or announcement of our workshop or tutorial. That's it, full stop. Okay? So please subscribe it. Okay? And also please keep in mind, if you change something, even an example, please copy it from our distribution directory and make another one, and make a copy. Then you can mess it up, or you can develop whatever the additional things. The thing is, when you install the newer version, if your example or modified example is in a original example directory, it will be wiped out. Okay, so make sure you copy it and start editing. Okay, and for sure you have questions in the future. Okay, then please first is look for documents. We have user's guide, tweak pages, tips pages, examples, and readmes. Okay, and if you unfortunately cannot find, and I forgot. All our presentations will be kept at least a couple of years. Okay? So you can always come back. Okay? And if you cannot unfortunately find any solution, then you are encouraged to post your question at this hypernews. But again, please, before you post your question, just read others, because most likely someone has already asked your question and got answers. And this is a best effort system, and developers will try our best to respond. But also, if you are confident to answer to others' question, please do so. It's a kind of helping each other. Okay, and if you post a question and you don't get any reasonable reply in a week or 2, except for Christmas or carnival season, it's exception. But then it's most likely that only 2 reasons. One is people have already fed up with that same question again and again. Or this question is beyond our understanding. Okay, only 2 reasons. Okay. So, please. And as a very final method, please write us an email. Okay. Our email address could be easily found. Just ask Google with my name, Dennis' name, Mihari's name. You find all of our privacies. Okay. But when you do so, please do not use anonymous email address like Gmail or Yahoo or this kind of things. Given our email address is public, suppose how many emails we receive. We have tons of filters, but still I have to deal with 100 emails a day. Okay? And also, if a mail comes from anonymous email address, we will never open attachment. Okay? Sometimes people say, "Hi Makoto," with whatever the unknown email address. Look at this, something goes wrong, please help me. I never open this attachment. No, it's too dangerous. So please, when you need to contact us, use your institutional email address. And in addition, in the subject, please say you participated in this tutorial. Okay, then that rings our bell, so we'll open and put priority on it. Okay, please don't use the anonymous email. Okay, and of course, if you find us, please catch us at whatever the conference is. And for example, if you look at Slack Geant4 team page, it's geant4.slack.stanford.edu. Then there are event page, and there, time to time, the conference is listed. That means at least one of us will show up on that conference, so you catch us, okay? But please don't be annoyed if I don't remember your face, your name. We have already met more than 2,000 users at tutorials. It's just impossible to remember everyone. So don't be annoyed if I'm just, who are you? Just please, in that case, just say you are here. Then, of course, you're okay. Okay. I'm okay. So please. Okay. And again, of course, so if some of you group up and build up some requirements or questions or common projects, that would be better, then just let us know. Okay? Now, the future. So, as I said, Geant4 is still evolving quite rapidly. So physics of the order of 100 TeV or higher is demanded for future circular collider and also for space or whatever. And neutrino interactions, yes. And electron hole drift in semiconductors. More phonon physics, channeling effects, and basically crystal physics in general, and X-ray diffraction. And further, someone asked the neutron scattering. But that is something not impossible, but we need resources. Okay? And single atom irradiation. Nowadays, photon factories, they are too bright so that each atom is hit twice. Okay? And target material polarization and chemical reactions, whatever the new domains. Okay? So, the kernel is quite robust enough for more than 20 years. It's more stable than Windows. Way more, yes. That enables the risk-free extension to all the new physics. Okay? So, of course, we do our best, but if you want to join us, just let us know. Okay? Yes, join us. Okay? And also, in computing side, supercomputers and also cloud computing. Nowadays, we know there are a lot of Geant4 applications running in Google, Amazon Cloud. Okay? So we have to deal with that. Seamless combination of MPI and MT, and smart data collection, and so on and so forth. For example, Docker, the containers. We are seriously considering about distributing Docker by ourselves. And in code re-engineering, for example, solid library. Recently, we have used solid, or so-called Beck-Geom. That really actually, as code re-implementation, re-engineered. Okay? Original solid was implemented 20-some years ago. So with modern C++, once we implement it faster. Okay? And EM physics, cleanup. And splitting transportation is going to come in this year or at the latest second year. That is, idea is now for transportation is a single process to take care of all the particles. Because of this, there are a lot of if statements. If this particle is charged, take care of the magnetic field. If not, skip it. But there are a lot of if statements that destroy the optimization. So if there is no reason we have to stick onto one process. So at least we have two, neutral and charged. And one additional thing is optical photon, because it has group velocity. So to calculate the velocity, only for the optical photon, there are a lot of complications. So there are if statements here or there. So we'll split it up. And sub-event parallelism. That is something that, for example, ALICE, or for example, high luminosity LHC experiment in general, one event is huge. Okay? So even one event is too huge to be tasked to single core. So we split primary event into some smaller sub-event and task to the different thread. But once this sub-event is tasked to the thread, it will its job without communicating to the others. And at the end of sub-event, it merged up to them. With this configuration, we can still minimize the communication between threads. That is the bottleneck. Still, we can deal with big event. This mechanism will be offered in 1 year or two. Okay. And GPU, someone came to me asking if there's any GPU. Unfortunately, at this moment, there's no successful alternative of Geant simulation in GPUs. Because GPU the thread divergence is really a killer. But for the case of the nature of the Monte Carlo, every step is randomized, and you have another particle, and so on and so forth. It's just quite instantly thread is diverged. So you cannot easily get the good performance in GPU. So, and also GPU, for the case of GPU, if you optimize the code to one particular hardware, it works, but it never works with other hardware. The CUDA language itself is still premature to describe the commonly work program. So if we distribute our CUDA code, that works for only NVIDIA one particular. What is this? What is JMF?
It's on your machine?
I don't know.
Some people's life.
No, please, don't do that. It's, do you have anything else? Oh, yeah. Stop it. How can I stop it?
Just click on the arrow, it'll ask you for later, I think. Or don't do it.
Yeah, but I cannot come to that screen. Oh, here it is. Okay. I don't know why they need this 46 minutes, 37 seconds. I don't know.
It'll be at the worst possible time.
Yeah. Anyway, okay. So there are several projects. Some of the Geant4 developers, including myself, are involving. But at this moment, I'm afraid there's no GPU code that could work commonly to all the GPU flavors. That's the reason why we are not yet releasing any GPU code. Okay? But in the future, things may change. OpenCL may be a solution. We don't know. So, yeah, Geant4 is dynamic, so you'll see. Okay? Anyway, even when we migrated to Geant4 version 10 series with multi-threaded mode, we didn't change almost any user interfaces. So we try our best to make our interface as stable as possible to make your life easier. Okay? So to sum up, as you have already learned, Geant4 is a general-purpose Monte Carlo simulation toolkit. Toolkit means there's no main, so you have to write main, and a few other things you have already learned. But it finds quite a wide variety of user domains, including, of course, high-energy nuclear physics, space, medical, material science, radiation protection, and security. And a lot of industries are using Geant4. This year of 2019 is our 20th year anniversary of the public release. Okay. At the end of 1998, we made public release. Okay. So after 20 years, with several major evolutions, we are still evolving. Okay? The latest big thing was multi-threading in 2013. And we don't know yet, we haven't yet decided if this coming release at the end of this year could be 10.6 or 11. But most likely it's 10.6. And there are some discussions of new development, but as far as we don't break users' code, we stick on to the same major version of 10. And when we really need to break your code, that means small changes in the API, so that you have to change something. We go to version 11. Okay? We don't know yet when. We'll evaluate every year the development. At the middle of the year, we decide if we are going to 11 or 10.5, or the next release is minor or major. And at the end of June, we are making a beta release. And at that time, we will say, this is a beta release of 10.6 or 11.0. Okay? And as Dennis said, if we change the major version, you may need to change some of your code, because we are going to change some APIs. if we stick on to version 10 series, next one will be 10.6. If that is the case, to utilize the new functionality, you may add something. That may happen. But at least you stick on to the functionality we are already providing. You don't need to change anything. Okay, that is the minor release. So at this moment, officially saying we don't know when it's 11. Okay, but for sure next major release is 11. Yes, 11 is after 10. That's it. Okay. So all these things, new physics, whatever, if we don't break your code, we just put it inside the new release, we still say it's version 10 series. Okay. So, and given Geant4 is nowadays used by a lot of mission critical things, not only high energy physics, but of course in high energy physics, but also medical or space applications. We have to keep evolving Geant4 for next decade at least. So you have quite a wide option to join our development, please. Okay, any question? Okay, otherwise we are done. Thank you so much.
Marcelo and Mauricio, we are willing to create a Geant4 forum for the users of this, for the participants of this workshop, and it will be open to other people that you know that couldn't be here, and then you know that they have interest in the sorry, and that they couldn't come for some reason because they didn't have funding or whatever reason, but you know that there are people out there that would have been here if they could, right? So we will create this forum, and this will be our way of understand what is going on with the community and make an interface with them through future more advanced forum or more advanced tutorial. Okay? So I thank you all for having come in here. Some of you came from very far, and I hope to see you again in another Geant4 event.